welcome to CHEM2005. Today we will talk about the synthesis of p-rolls, and we will talk about the synthesis of p-rolls that commonly has this type of structure. Okay? Remember that the last day we was talking about how to synthesize p-rolls where this position and this position are hydrogens, that is a 1,4 carbonyl compound. Okay, but here we will talk when we have an ester in this position and in this position, I mean in C2 and C4 position. Okay, here and here. If we do a retrosynthesis, this time in state 2 breaking, here we can see that we can break by this carbon-carbon bond. If we check this carbon-carbon bond, can be coming from an aldol reaction, isn't it? This is a nucleophile. We have an ester that can form an anion here, and then this can attack here. And what we have is okay, what we have is this compound, and then what we can see is that, like we did before, this is not anymore than an enamine, isn't it? And remember that the enamine basically is the addition of a amine to a carbonyl group. That means that this can come from okay, this compound plus this one, that means this amino ketoester with this ketoester. These are the precursors to synthesize this, and these can come from a ketoester. Okay, that means that we need only two different ketoesters or the same ketoester, and we can synthesize this type of p-rolls. How we can do it? Well, first of all, I will explain how to synthesize this compound, okay, and then we will synthesize all the p-rolls. To synthesize the amino ketoester, we start with the ketoester, okay? And what we add is, for example, this compound in acid. This basically what we are doing is generating in situ this compound, this nitroso compound, the nitroso cation. Okay, and what is happening is that what we get is the formation of this attacks here, and what we have is the formation of this oxime, okay? the mechanism of this part is on the notes, and then this is treated with zinc in acetic acid. Okay, we are reducing, and what we get is the aminoketoester. This is how we synthesize aminoketoester. Okay? Easy. Please check this mechanism in the notes. Okay, it's quite easy. And the reduction of the oxime to the amino is not necessary to know the mechanism. It's so advanced for this course. Probably you will know it in the following years. Okay, but this is how we synthesize aminoketoester. Basically, we react a ketoester with this compound in acid media. Okay, this is what the only that is doing this reactant is generating this nitroso cation. Okay, and then remember that this is nucleophilic, this position, because this is in the middle of two carbonyl groups, attacks the nitroso to generate the oxime, then we reduce the oxime to generate the aminoketoester. Right? Okay, then what is happening when we have the aminoketoester? When we have the aminoketoester, this is reacting with a second aminoketoester. Okay? That could be a new one aminoketoester, or basically the same that we started. What is happening is that we are in acid media. That means that we protonate the carbonyl group, and then the pair of electrons of the mean are attacking this, and what we generate this intermediate, and again we move this proton from the nitrogen to the alcohol because we want to do elimination, we want to form the imine, and what we get is we generate this compound that now we have the elimination and formation of the imine to obtain okay, we eliminate water. Okay, we have this ion, this intermediate, cation intermediate, and what we have is we eliminate protons, and what we get is we generate this intermediate. When we have this, basically what we need to do is tautomerization imine enamine. Okay, what we get. We have isomerization, and now we know that this position is a nucleophile. Basically, we are in acid media. That means that we protonate this carbonyl group. This position is nucleophile. That means that this will attack the carbonyl. Okay, if we do all the electron jumping well, and what we have is we will have this cyclic compound, okay? And now we can do, for example, we move this proton from here to here, okay, in order to make this a very good leaving group. Okay, I will continue up. Okay, the only that I do is to transfer this proton from the nitrogen to the wedge. You can do it in one step, in two steps, up to you. Okay, what we get. Okay, we get this. We generate this intermediate, and then we eliminate water. We can do a E1 elimination. My cat is playing here. Okay, we can do a E1 elimination. We generate okay, and then simply we do the elimination with the proton, we eliminate the proton, and what we generate is okay. One, we have this, simply tautomerization, imine, enamine, and what we have is the final pyrrole. Okay, this is the mechanism how we form the pyrrole. Okay? Please take a look. You have the same mechanism in the notes. Please follow, try to do it by yourself in order that see that you remember all the steps. Basically is when we have the amino ketoester is the formation of the imine, intramolecular aldol reaction, and then elimination.